operational amplifier circuit in Proteus. So Proteus is a software, you can do multiple things with it, millions or billions of things with it, but today here is the Proteus software. You have to run it in administrative mode to find the libraries. Now as you can see, there are some design rules here, and this is the schematic capture window what we are going to use here. So when you enter this window, you will find this window will appear here, and now you will have to pick some objects, like which object, which circuit you want to create. So we want to make an operational amplifier, so we have to search for the element. If it's there in the Proteus library, it will show here, and here you can see as the 741 op-amp, which is an operational amplifier. Then we need some feedback elements like resistors, capacitors. As we are doing only the amplification and frequency response, we don't need capacitors. Capacitors are needed for integration, differentiation and other works. So at first we have to make in Y mirror, because we want the inverting terminal in the upper portion. Usually we do it in the examinations and all the things. So let's place the feedback resistor here and the input resistor here. So connect it. We are making the feedback path from input to output using a 10 kilo ohm resistor. Then we need an input signal, which can be found here. This is a sine wave. We are putting this sine wave here. After that, we need a positive and negative supply, because we need to bias the operational amplifier in positive and negative supply, give the voltage sources. For that we can connect two batteries in series. Okay, we have to choose a battery, two batteries in series. This is the reference point, which will be the ground. This will be the negative input terminal, and this will be go to the positive terminal. Now we can make it 180-degree phase shift, because this point is the positive terminal, go to the pin number 7, and this is the pin number 4 will have the negative terminal. So we are getting 12 volt minus to the pin 4 and 12 volt plus to pin 7, and there is the reference point which will go to the pin number 3, which is the non-inverting terminal, as we are using this as a inverting amplifier mode. So we need an oscilloscope. Now before that we have to change the frequency, because 1 Hz frequency is close to DC signal. Now this is 1 kilohertz. The sine wave will have a 1 kilohertz frequency. Now we need oscilloscope. Here you can see there's oscilloscope. The oscilloscope will be placed here. There are 4 channels. We'll be using channel A for output, channel B for input. Okay, now if we just place the simulation button, you can see here is the input and output signals are here. Okay, the blue one is blue, right? Okay, the blue one or channel B is the input signal, and here is the output signal. And actually this signal is not amplified. You can see 1 volt peak. Both signals are 1 volt peak, because we did not change the resistance value. The feedback and input resistance have the same value. So if we change the feedback resistance by 20k instead of 10k, then gain will be -2. So here you can see the output signal will be amplified, and it will be 2 volt peak now. Now if we want to see the frequency response curve, we can also see the frequency response curve in Proteus. For that we need a probe, which will be connected to the output terminal where we want to see the frequency response. And here is the different types of graphs are there. Here we can see the frequency response curve. So this window will show us the frequency response curve, gain versus frequency. So we need to do some change here, frequency response, and we need to choose the prove here. After that we edit the graph, and frequency ranges from 10 Hz to 10 megahertz now. Okay, if we simulate this, edit graph, it will be now frequency response, just name it. Okay, edit graph B. Here you can see is the frequency response curve here. Now until that point, the frequency in the frequency response curve, you can see the gain is not changed, because until a specific frequency the amplifier gain will be the same, and after that the frequency, as the frequency increases, the gain decreases. So we can also find the 3 dB point, which is the half power point, which is 0.707 multiplied by V maximum from here. And also if you see the gain versus frequency curve here, so in 10 megahertz it's close to 0. Actually in ideal op-amp the frequency response curve will have a infinite frequency response, any op-amp, but as the Proteus is designed in such a way, then it will follow the practical rule. That's why we are having this curve here. So we can also see the gain input and output curve. Here is the input output curve, and here is the frequency response curve.